Welcome. In this lesson, we're going to review the sine and cosine and teach the tangent of A. Now remember, these are all trig functions or ratios. So last week we learned the sine of A is the opposite side over the hypotenuse. Cosine of A is the adjacent side over the hypotenuse. And today we're learning that the tangent of A is the opposite over the adjacent. But those sides all depend on which angle we're referencing. So for this particular problem, we're referencing angle S, or the cosine of S. So I'm going to look here at S. I always identify the three sides first. I first identify the hypotenuse, which is the longest side or the side that's across from the right angle. The hypotenuse never is one of the two sides that forms the right angle. It's the other one. Then I like to go across from S and find the opposite side. This is the opposite side. Or it might be easier to find the adjacent, which is the side that makes angle S with the hypotenuse. So this side that's 8 here is the adjacent side because it makes angle S with the hypotenuse. Now I look for the ratio. Which ratio do I want? I want the cosine ratio, which is adjacent side. It's 8 over the hypotenuse, which is 17. So I'm going to type in 8 over 17. Now, pause this video and write these three ratios down, right? The sine of A is equal to opposite over hypotenuse, cosine of A is equal to adjacent over hypotenuse, and tangent of A is equal to opposite over adjacent, because we're going to be referencing those and you need to be able to see them, and I'm not going to take the time to write them down for every single problem. But now I'm going to type in this ratio of 8 over 17, 8 over 17, and move on. And again, if you get good at this, you'll see that it should go fairly quickly. For this one here, I'm going to take the tangent of J. Here's J. First thing I do is I identify the hypotenuse, and then I identify the opposite side, because that's opposite J. So this is opposite, and then I identify the adjacent side, which is the side that forms angle A, or angle J, with the hypotenuse. Tangent is, look at your paper that you just wrote them down on. It's opposite over adjacent. Opposite over adjacent, 72 over 65. And then, if possible, always try to reduce that fraction. But I believe 65 has just a 5 and a 72. 65. 65 is 5 and 13. And 13 does not go into 72, so we're good. It doesn't reduce. But try to always reduce. I'm going to jump ahead because I want to show you how to do one with square roots. So I'm going to go look for one of those. Here's one with some square roots. But let's first find the ratio. Sine of y. Here is y. Here's the hypotenuse, because it's across from the right angle, or the side that doesn't form the right angle. This would be the opposite side of angle y. And then this would be up here would be the adjacent side, because it forms angle y. So when we're asked for the sine is opposite over hypotenuse. It's the square root of 42 over the square root of 58. Now here comes the hard part that you're not going to remember how to do, or it's called rationalizing the denominator. And rationalized form means I can't have a square root of 58 in the denominator. So what I do is I multiply by 1. Yes, you heard me right, by 1. But what that 1 is going to look like is the square root of 58 over the square root of 58. Any number over itself is just 1. So I'm not changing the value of the number. What I'm doing is I'm just eliminating the square root in the denominator, because the square root of 58 times the square root of 58 is going to be 58. Now I'm going to grab a calculator and multiply 42 times 58 and get 2,436. But now we got to be careful again, because in Monday Spiral Review, I gave a bunch of reducing radicals or simplifying radicals. I know this 2,436 is at least divisible by 4, so I'm going to divide it by 4 and see what I get, which I get 609. Which is also divisible by 3, but it gets me 203, and neither of those have smaller factors at square root. So in other words, what I'm saying is 2,436 has a factor of 4, which I can square root as a 2 square root of 609. So what I'm going to do is I'm going to rewrite this as 2 square root of 609 divided by the 58. But again, 58 and 2 have 2's in common. So that's going to reduce to just the square root of 609 over half of 58 is 29. And that's what you're going to type in over here. You're going to do a fraction. You're going to do the square root of 609 and over 29. Again, this takes a little work because it has to do with reducing these radicals. Now in this one, we're missing a side. We're missing the hypotenuse. So again, I'm going to remind you of the Pythagorean's theorem. A squared plus b squared equals c squared. Where a and b are the two sides that form the right angle, c must always be the hypotenuse. I don't care which two you make a or b. I could have made this a and this b, but a and b has to be the two sides that form the right angle. C, the one that's by itself on the one side of the equal sign, must always be the hypotenuse. Now, I have some square roots involved. So when you square, be very careful. I have to square the 2, that's 4. But the square root squared, or the square of the square root, just cancels, leaving 19. So I have a 4. And again, please pay attention and look at this. This 2 got squared, but the square root got canceled, which means I'm just left with the 19. This 2 got squared, that gives me 4. The square root gets canceled, leaving just the 6. So 4 times 19 is 76. 4 times 6 is 24. I add those, I get 100 equals the c squared. The c squared being 100, c would have to be 10. So I can write 10 up here. Now I can write the ratio of the cosine of w. Here's w. Cosine of w is the adjacent side, which happens to be this 2 square roots of 6 over the hypotenuse, and this is the hypotenuse, so over 10, and then you just reduce, because 2 goes into 10, and we're left with the square root of 6 over the square root of 5. Not the square root of 5, sorry, over 5. Square root of 6 over 5. So I come up here and I type in a fraction, square root of 6 over 5. Now, if there had been a square root in the denominator, I would have had to rationalize like on the last problem. Again, if you have issues or problems with this, please utilize time in class. We have an hour and 20 minutes now to ask me questions on how to rationalize denominators, how to use Pythagorean's theorem, reduce radicals, and you should be able to do this assignment